And we should be live. Hello, hello. And if you're already here, definitely say something in the chat. It's always fun to hear or see who's watching, maybe hear where you're watching from. And if you want to share extra details about what you're working on with machine learning or MLOps, that would be pretty interesting too. And we're going to get going here in a couple minutes. It's not even quite 10 yet. So again, if you're already here, say hello in the chat. Also, for anyone tuning in or watching the recording, I'll share some resources in the chat as we go. But if you want to follow along, all the resources are also in the description. So feel free to poke around in the description, find the code notebook, and you can go ahead and start playing around with it if you want. But I'm going to be walking through all the code cells here shortly. So again, we're going to wait a couple minutes before we get going. Shirang already said, enjoyed the book club yesterday. Glad to see you here. It was great. Thank you for coming up and talking a lot yesterday. It's really fun to hear about other people's experiences. So yours is really cool to hear. And yeah, as people are joining in, say hello in the chat, and we'll get going here in a couple minutes. While you're also waiting, or while I'm waiting for people to kind of start rolling in, if you're already here, the thing that might take a few minutes for you to set up is creating a Union account, which is the platform we're going to use to build our ML pipeline today. You can sign up there for free. There's no card or anything required. You just authenticate with your GitHub account. And just a note that it says like join waitlist. Go ahead and hit that join waitlist button. And then it'll take about 5 minutes for you to get a confirmation email. Once you get that, then you should be able to go to the URL. Again, I'll share all this when we get to it and when it's really important for you to follow along. But then you can go to the serverless URL and have your account there. While we're waiting, I'm just going to make sure that we are kind of streaming in all the right places. And people will probably start rolling in about now because it's actually 10 o'clock. Just going to make sure. And for anyone watching, make sure, it's always good to have a second confirmation that you can hear and see the screen as well. Looks like people can if they're already commenting, I'm guessing. And I'm just going to make sure that send out the email with the right live link. But yeah, as people are joining, I see a couple more people joined. Say hello in the chat and maybe a little bit about what you're working on if you have any specific projects. It's really fun to hear about, what people are doing. And also I can kind of cater a little bit about what I potentially talk about as we go along to maybe fit your needs. So definitely share that in the chat. And again, we'll get going here in probably another minute or two just to allow some time for people to pop in. While we're doing that, too, I can actually give you a little preview of what we're going to build. This is a platform. We're going to use a Python SDK, so we're actually going to run a lot of code today, and you'll be able to follow along with everything. We're going to build a pipeline to train a large language model. Our example today is going to be fine-tuning a BERT model, and we're going to fine-tune it for sentiment classification. But all the stuff we're going to talk about today can be useful for more complex models and pipelines. So if you're using something that isn't a BERT model and something more complex, you can kind of implement what we're going to do here today with that. But the BERT model makes it easy to follow along for the workshop, and we can actually fine tune it in a timely manner and get results right away versus using a bigger model, which you can also kind of implement the pipeline with a bigger model. So again, this is a preview for people just joining in. I'll get back to the slides here and how to set up. Again, we're going to build a pipeline that's going to download a data set. It's going to download model weights. We're going to fine tune that model. We'll also visualize the data set, and then we'll evaluate the model once it's fine tuned. We'll save a version of that model to Hugging Face Hub. And then we'll also kind of have an extra task to predict sentiment on text that we pass in. Again, for people who just joined in, say hello in the chat. Maybe talk about where you're watching from, why you're interested in building ML pipelines, or if you're building something with large language models, let me know in the chat. And again, all the resources are in the description if you want to follow along. The main one, if you want to kind of sign up right now, because it can take 5 minutes or so to process, you can sign up at Union.ai, hit that sign up button, or go directly to that sign up link. And this is going to be the platform we're going to be using, and using a Python SDK to interact with it. So I'm going to go ahead and get going on the slides here. I'm sure more people will come in. We're going to do some slides, and then we're going to do probably mostly kind of hands-on. Feel free to ask questions as we go. I'll share this link too in the chat, but again, it's in the description. This is going to be the code notebook that we're following along. You can hit that open in Colab button. That'll directly take you to the environment that we're actually going to be using for the workshop. So again, feel free to poke around, get started poking around, but I will walk through everything as well. So a tiny bit about me. My name is Sage Elliott. I work at Union.ai. I live in Seattle. I run an AI book club. Someone even in the comments has already mentioned it, how they were there yesterday. It's really fun to read. We read a new AI book every month, so go check it out. Previously, I've done a lot of work with computer vision, ML monitoring, and evaluation, and then that kind of also went over into LLMs in the last couple of years. And then I've also have a background of doing hardware and IoT, and also a lot of MLOps now. And if you want to stay connected with me, do so at LinkedIn. I'm pretty active on there. And then also, if you want to stay connected with other people too, and maybe provide a more permanent introduction to of yourself, so you can join the Slack channel. There's a lot of communication in there that happens. I think there's over 3,600 people. If you want to talk about MLOps, and Flyte is the open source MLOps platform that we're going to kind of see a preview of today. So again, about you, again, seeing more people come in is perfect timing. Post in the chat, where are you watching from? Maybe what you're working on. Why are you interested in ML pipelines or LLM pipelines? And then again, you can join that Slack channel. Again, all these links are in the description below too. And do a more permanent introduction in there. And I'm going to catch up on some of the use cases people are talking about. I love it when people talk in the chat. It's definitely way more fun for me. It's probably more fun for other people watching as well. So instead, their use case is ingestion, processing of structured financial deal documents, data capture, and eventual generation of Python code that represents the waterfall rules. That sounds pretty cool, and definitely something that you can build with kind of like some of the pipeline we're going to see today. You could actually build out maybe I don't know if you're planning on using something like a RAG. We actually have a RAG example that is linked to at the bottom of the notebook as well. That might be really relevant for your use case there. Someone else said they're streaming from the Pacific Northwest. Me too. In Seattle, like I said. Someone said they're LoRa fine-tuning scientific papers for various downstream tasks. And fine-tuned models need low latency serving. Looking forward to the talk. Awesome. Very cool use case. Someone said they're streaming from Pakistan. Awesome. Hello. Someone's from Austin, Texas, and they have a decent background with ML. And until convolutional neural networks and recurrent neural networks, but since the onset of LLMs have been out of touch. Awesome. Well, welcome. We're going to be fine-tuning LM and building a kind of reproducible pipeline around it. So hopefully this will be a really kind of fun introduction to building like production grade pipelines, and then also potentially LLM fine-tuning. And someone said they're a PhD student with NLP. Awesome. Again, feel free to keep talking in the chat and join the Slack and keep talking there if you want to have more permanent introduction again. A quick overview of what we're going to do today. First, I'm going to do kind of a concept overview in some slides. And then we're basically going to go ahead and create this pipeline. We're going to create a container image. If you haven't created a container image before, again, don't worry. We're going to do it in a little bit more of a simple way, which is really cool. I don't know if you've ever looked at Docker, or if you love Docker or don't like writing Docker files. Don't worry. We're actually going to use a Python snippet that's going to do it for us, which is really cool. And then we're going to build a pipeline that downloads a data set, downloads the model weights. We're going to process that data and visualize it. Actually, we're not going to do much processing today because it's a pretty clean data set. But if we were, we can talk about it, and we'll also visualize the data set. And then we're going to fine tune a BERT model on that data set, and then we'll evaluate the model. We'll save that model to Hugging Face Hub. If you haven't used Hugging Face before, one of their things that they have is a popular transformers library that we're going to use, but also a hub where you can save data sets and models. It's very popular. And then we're going to use that model to predict sentiment on new text. We can pass that in the task in our pipeline, but we'll also look at how to interact with that through a Python SDK once you have this kind of trained model. So you'll have a form of deployed model that you can interact with as well, which will be awesome. So everyone ready? Um, First, if you haven't seen kind of a MLOps or LLMOps pipeline before, I'm just going to quickly show what one might look like. In this case, this is a pretty simplified version, but most of the time you're going to have something that looks like this if you have any type of model in production, not just LLMs. And MLOps is kind of the set of practices and tools that usually aim to deploy and monitor and maintain those ML models in production more reliably and efficiently. Also, a quick question for anyone in the chat. Have you ever put a model in production before? And have you ever built kind of a pipeline that might have some of these steps? So typically you have data collection. Then you're going to use that data to train a model. Again, you might have more steps like cleaning the data, pre-processing the data, feature engineering, etc. This kind of simplified here. Where you're going to train the model, you're going to evaluate the model, make sure that it is working kind of how you want, and then you're going to ship that model. And that looks very different depending on your use case. That could be deploying to a small hardware device. It could be deploying to SageMaker Cloud. It could be deploying, to a different space. Maybe it's something you run locally. And then typically you have some sort of monitoring. Has anyone done some form of ML monitoring in the past? So once your model's in production, usually that's not it. It's like a whole living application. And you kind of have to build out a system where you can look at the model in production in some way, see if it's performing as expected. And if maybe there's new types of data coming in that your model wasn't trained on, you can kind of then collect that new data in production, retrain a model, and you're basically building a ML lifecycle where you're doing these steps on repeat. And again, there's a lot more that can go in there, like the processing data, prompt management, vector databases, guardrails. You also might want to do something like shadow deployment or A/B test deployment, where you have that new model trained, you ship it out, look at how it performs on production data, but you have the old model there too, and then you can make the best or select the best model that's performing on that new data. So typically, you're building out kind of like this performance wheel where you're doing all these steps over and over. Has anyone done something like this before? I think someone in the chat said yes. Awesome. And you probably know it's important. Like, have you ever had something weird something weird happen in production with your model or data before? Usually can't just put a model out and then expect it to behave perfectly all the time. There's a whole bunch of variations that can happen. So we're going to see kind of how to build part of this today. There's a whole bunch of tools to do all these different steps. So has anyone used any of these tools before? I'm not going to read every single one, but here's a whole bunch that this is just a small sliver of all the tools in the space. You might have seen that graphic that has like hundreds or thousands of tools in it now. This is a small sliver, and you might, again, extract, transform your data, validate it, you explore it, train your model, test, deploy, monitor, and retrain with all these different libraries. And we're going to see kind of how we tie these together with an AI orchestration platform. We're going to use something called Union today, which is built on top of the open source platform called Flyte, Flyte. We'll talk a little bit more about this as we go. But I also just want to mention the stuff we're going to do today with the Union platform, you could re-implement on the open source Flyte if you wanted to. But it has a little bit of setup. So we're going to use a version of Union called serverless that is going to make it really easy for us to follow along today in the workshop without having to set up your own cluster or anything like that. So hopefully it'll be really easy. But at the core, like I said, is orchestration, or often within ML applications, we call it ML orchestration or AI orchestration. It's kind of the core of most pipelines. Really allows you to make reliable and efficient workflows, kind of like what we saw before. But there's a whole bunch of stuff that you might want to think about when you're putting this in production. Scalability, you want to facilitate the scaling of those workflows to handle really complex data sets and models often. Reproducibility, you want to ensure that the workflows can be consistently run and reproduced. So every time you run a workflow, it should, basically be handled the same and give you the same results. Versioning, this is a big one. You've probably, most of you, I'm guessing, have used GitHub before. You're versioning your code. Why not do that with all of your pipeline, including like your data, the code, for LLMs, the prompts in there, and then models. Every time you train a model, you have a different version. And then you want to have improved efficiency, where you allow your data scientists and ML engineers to focus more on the development and hopefully a little bit less of the ops. There was a really good quote by someone talking about how they were building pipelines in a big company. They said, my ML engineers shouldn't have to write a Jira ticket to get a model out. And I thought that kind of resonated with me a little bit. I don't know if it resonates with anyone else. And then also, a big factor to consider is cost efficiency and optimization. So we'll talk a little bit about a couple things I've seen actually when people adopt like a modern orchestration tool that can really save them a lot of cost, not just like financial, but also time when you're developing AI models. So if you're choosing an orchestration tool, a couple things to keep in mind that or a couple things I would keep in mind is optimize for local and cloud development. So some tools you basically set up a cloud cluster, and then every time you run a workflow or a task, you kind of have to run it on there while you're developing it. So I'd look for ones that you can do local development, which you can with Flyte or Union. So you'll see we can write some Python code. We can run it locally. So as long as you have compute for all the stuff you're doing, you can quickly iterate on there, which is really nice. Versus like kicking off a whole cloud container, waiting for it to run, and then going from there. Leveraging caching in the pipeline. Here's a quick example of downloading a data set, pre-processing that data, and then we train a model. If we're running the whole workflow every time, chances are, if we have that same data set, we don't need to re-download the data set. We don't need to pre-process it again. We just want to train the model with different hyperparameters, let's say. So this is a way to kind of save a lot of computational resource where you're not downloading data again, potentially, but you could use this for any task where you think you don't need to do the whole task again. You just want to have those saved outputs and reuse them. So a common one is like hyperparameter tuning for models. We have task level resource management and containerization. So you might have heard of orchestration before and think of like LangChain, where you're just tying together tasks. But like Flyte manages your whole resources as well, all the computational resources around your pipeline. And this is important because, again, if we had a workflow like this and we need a GPU to train our model, maybe we don't need the GPU for all these other tasks, though, like downloading the data set or pre-processing the data. And these can potentially be really long tasks if you have large data sets. So having something where you're defining the containers, but also the exact compute to run every task on could be really beneficial. So you're not basically wasting GPU time or, excessive CPU time for all these other containers. And again, we'll see how to do this today as well with just declarative infrastructure in the Python SDK. Mitigating errors with type safety. Has anyone used typed languages before, or maybe added typing to Python? This could be really helpful for kind of debugging, but also like safety and data integrity. If you're especially working across a team, you're defining tasks of your pipeline. You can reuse these tasks. People can come in and actually see exactly what type of data is coming in, what type of data is coming out. And if you do something, in the task or from another task, you're trying to pass in the wrong data, it'll kind of yell at you and give you an error. And then you should rethink, oh yeah, I didn't tie these tasks together correctly, and it wouldn't have given me the outcome I was expecting. And then one thing that I feel like a lot of people don't talk about is harnessing the benefits of using stuff like spot instances or batch processing. Um, I don't know if anyone's looked at like AWS spot instances before, but oftentimes they're quite a bit cheaper than paying for just your own compute that you want to spin up. And if you can utilize that, that can save you a ton of money. So you can look at kind of some of the orchestration platforms that allow this to happen, where you can have like interruptible tasks, where if something like the compute goes down, you can kind of rerun it again. I'd look at that for features, and also just keep it in mind that there's different ways to use batch APIs or batch, uh, yeah, batch processing, not just APIs. Like um, OpenAI has a batch processing API now, and it's like 50% cheaper than using their OpenAI API. So if you're okay waiting, potentially, I forget how long it is on there. I think it's up to like an hour or two, but oftentimes you don't need live predictions. You can wait that time if you're processing a lot of documents or something and you're not powering a chatbot. That's totally fine. Um, so yeah, keep that in mind. It can save you a lot of money when you're building pipelines as well. So again, today we'll be using Union. We're going to be using a version called serverless, which is in beta. So if you do happen to see any bugs, let me know, and we can go ahead and fix them. And yeah, just noting it's in beta. And it's built on top of the open source project called Flyte, Flyte. This originally was Lyft's internal orchestration tool. So any big company doing machine learning and data processing at scale are probably using some sort of orchestration tool internally. That can be one like Flyte, which is pretty widely used, maybe one of the more widely used open source platforms out there. And or they might have their own internal one, like Lyft built their internal one, then they open sourced it, and now it's part of the Linux Foundation officially. And then Union is kind of a managed version of it that makes it even easier to run. And we'll see this in serverless. It's going to feel almost like magic. If you've ever set up a Kubernetes cluster before, you're going to be like, wow, this is really, really easy to run. But go check out the open source. I'll share a link in the chat, but again, it should be in the description as well. And of course, we always appreciate a GitHub star if you're logged in. It's easy to do. And again, we'll see this in action, but every single task, like we talked about building that pipeline and having all those tasks, every single one of those inside Flyte is going to be containerized. So it runs in its own container that we could define. It's going to be versioned. So all the inputs, outputs, and the code and the version of the artifacts that it generates are going to be versioned, and it's strongly typed like we talked about. So in there, and we'll see this all in action here in a second, but it has a declarative infrastructure where we basically say the compute that we want to run these tasks on with Python. Again, built-in versioning. I keep saying versioning, but it's incredibly important and something a lot of people look for when building reproducible pipelines. Has caching built in, like we talked about. So if you don't want to rerun a task over and over again for your whole pipeline, it's very easy to do. Type safety, it's incredibly flexible. There's a large plugin ecosystem, but also out of the box, it can work with probably most of the ML libraries that you're looking for. But if you are running something on like Spark or anything like that, you can also check out I think that one you might need a plugin for, but check out the massive ecosystem there built by the awesome open source community that we have. Checkpointing, and it's scalable. So it's built on top of Kubernetes. So if you want to spin up more and more compute clusters for all these tasks and workflows, it's very easy to do. And then again, we'll see this really nice user interface that we can do, but also the Python SDK. And just today, we're going to be using a BERT model from Hugging Face library. And I'll share the link to the BERT paper and code if you want to check it out. But it stands for Bidirectional Encoder Representations from Transformers. It's one of the earlier kind of really popular transformer models that people started adopting, and we're going to fine tune it. So that means we're going to pass in new data to it, and then kind of give it some labels in this case because it's going to be predicting for negative or positive sentiment. Again, this could kind of scale to other use cases though, and then we'll pass in new data and get a prediction from it. And then for the saving and versioning models, we're going to be using Union, like we talked about. That's kind of built-in versioning there. We'll also talk about how to move a model off a Union into something like the Hugging Face Hub, where then you could, maybe use different deployment methods that you might be familiar with using Hugging Face Hub, or you might deploy it directly in a Hugging Face space, which is pretty cool. All right, so let's build a pipeline. We went through some slides. A lot of people joined in during that. So here is the repo again. I'll share the link, but also it's in the description. Where's my copy button? There we go. Also, is everyone ready to follow along? And again, you'll need a Union account for part of this, or for most of it. This is going to be the platform we're building in. It can take 5 minutes for you to get approved, or it'll say join the waitlist. Hit that join waitlist button, authenticate with GitHub, and then again, it might take up to 5 minutes for it to get processed. So once you open up this link, you'll get this GitHub page. And then what we want to do for the workshop is you can just hit this open in Colab button. And that'll take you to this Colab space. And I can share the link directly to this too in the chat. But again, links to everything is in the description. And the first thing we're going to do is go ahead and hit this little play button on this installing packages code cell. And I'll talk about, actually first, what I might recommend, you can do that, but you might want to save a copy in your own drive. You can run it without doing that, but I kind of like saving my own copy when I'm following along with a workshop. That way, if I'm editing code or text or anything like that, I have my own copy and I can reference back to this. If you break it, don't worry. You can always come back to this original version, make your own copy again. So I do recommend hitting File, Save a Copy in Drive, and then you'll get your own. If Colab will load, there we go. I have a copy of BERT Fine Tune. I'll zoom in a little bit here. Oops. In, not out as well. Hopefully that's good enough, but let me know in the chat. All right, so go ahead and run this first code cell, and I'll kind of talk through some more stuff that we're going to be doing here. This can take a few minutes to run, just because it's installing a lot of packages that we're going to use. Again, we're going to use Union. We're going to use a transformer package, which is by Hugging Face. Datasets is by Hugging Face as well. It allows us to download a dataset in this case and interact with it. Matplotlib to make some charts. PyTorch, Accelerate for the that's used for the fine tuning piece. And then we're going to use scikit-learn to get I think we're actually just using classification report, but it's a really popular machine learning library with a lot of other models in there, but also some useful tools for like analyzing your data. So again, this can take a couple of minutes to install. So hit the run code cell here. And if you've never used a Jupyter Notebook before, this is kind of Google's way of hosting one. This is called Google Colab. They also give you a good amount of free GPU time. It's a really great tool to kind of learn deep learning on, especially if you don't have a GPU at home. Which we won't be using the GPU today, but just want to throw that out there. And then you can run these code cells by hitting that little play button, or when it's highlighted, you can hit Shift Enter. So you'll probably see me doing that a lot this workshop, where I'm not hitting the play button, I'm hitting Shift Enter. But it allows you to kind of write code, documentation, and see the outputs all in one place if you haven't used a Jupyter Notebook before. And while this is going, because we have a couple minutes for it to install, again, if you haven't already, sign up for Union. Then once you are signed up, you can go to this link, this serverless.union.ai, and it will take you to a page that kind of looks like this. Yours will probably be empty. I have stuff that I've run in here before. But we can start seeing I have all these execution IDs, and these are all the different executions I've run in the platform for the last 24 hours. I can also explore, what I've done in the last month, etc. And you'll also want to make a Hugging Face account if you don't already have one. Again, Hugging Face is a really popular, not only a library, like the Transformers library we're going to use today, but also a place to save models and host models. And so you want to create a Hugging Face account. And I can go over this again when we get to the actual part. But once you create an account, go to settings. So you can go to your little icon here, go to settings, and then go to access tokens. We're going to want to create a new authentication token to be able to upload a model to Hugging Face. So then you can hit create token. And I'm pretty sure if this is grayed out for you and you just created your Hugging Face account, I think what you have to do is verify your email, and then you should be able to create a new token. You could give this any name. I'll just say workshop LLM. And then I think we really just need write access for writing a model to your hub. I usually just go ahead, or in this case, I'm going to go ahead and give my token read and write access. In case you wanted to use the same token again to pull down the model, you can. And then you scroll all the way down and then hit create token. And then you'll have a token here. And again, I can go through this again when we get to the point of actually entering it in. But if you wanted to go ahead and do that, perfect as well. And then we'll really be set up to run once these libraries are done installing. Also, I don't know why, but Colab used to show like the progress, and then for some reason recently it stopped. And so you're kind of like, I don't know what's happening. It's just spinning, and then it'll just output all the chunk at once. And I'll fix the spelling error later, but this is how we authenticate our Union account. Has anyone created the accounts that we talked about in the chat? Chat has been a little bit quiet. Someone said Colbert is the dude. I assume that's another version of the BERT model. I don't know if I've heard of. No, I think I might have heard the name a long time ago, but I don't remember what Colbert does or the difference between it. Yeah. Was anyone able to make an account? Cool. Someone said yes. And did you get the authentication approval email? Also, sometimes I don't know if it's when I'm like live presenting, it feels longer, but sometimes Collab takes a little bit longer to run than normal too, which I feel like might be happening, or just my time perception is off. Awesome. Someone said yes. People are all right. So who's following along? Awesome. So RB said they already have the account. Perfect. Thank you. Always great to hear confirmation. Again, this shouldn't take too much longer. While that's going, and I can see when it stops, when this turns kind of the gold color instead of gray, can bring up my dashboard again. and just give you maybe a little bit of a tour of this interface. So again, we'll be building tasks and workflows with Python in the code notebook, and they're going to end up looking something like this. This is the fine-tuning BERT workflow that I previously built. We can see we have all these different tasks. So a task is kind of, a single thing you want to do in your pipeline, and you create them by writing Python functions, which we'll see here in a second. And then you just add a little decorator around it where you can add in other variables. But we'll create all these, this download dataset, download model, visualize data, train model, and then we'll get a whole workflow that looks something like this. So I can see my notebook is done installing those libraries. Did anyone else's notebook finish? Once yours does finish, run this next code cell, which is union create login. We're just going to authenticate this environment. Every time you come back to this notebook, because the compute for the notebook isn't up all the time, it's just an instance, you'll have to run this again. But if you're developing locally, you just basically do this once in a while or once on your local machine. You'll be authenticated. And I kind of walked through that very fast, but I open up this link. It gave me a button to press. Don't worry about changing any of those letters in there. That's just an authentication code. It's already pre-populated. Just hit accept, and then you should get this login successful. Awesome. And RB said there's finished installing. Fantastic. And if you got this login successful, very good. We should be able to start going through the rest of this pretty easily. Also, so we're going to build a very simple workflow first, and then we'll build the more complex one. But I'm just going to break down again tasks and workflows for you. And I want to quickly note this write file magic function, I think is what they're called in Jupyter Notebooks. This isn't a Union or Flyte thing. This is something in Jupyter Notebooks. So with Flyte or Union, you want to create Python files that contain your workflow and then run them from there. There's this nifty little thing called write file, and it's going to create a Python file with all the code under it. So when we run this, I can hit Shift Enter, and it says writing simple workflow.py. That's what WF stands for. And if I open up this little Explorer icon, I can see that it contains simple workflow.py, and this actually contains that Python file that we want. So I'm going to break down this Python file now. We're going to import libraries we use, which from FlyteKit, we're going to import task and workflow. And we can see we just have two very simple Python functions here. The first one's called hello world. It's taking in a string. And remember, this is strongly typed, so it's required to have the type of the variable coming in, which in this case is a string. And that's also required to kind of tell you what the output of the function is going to be, which is also a string in this case. We're going to take in hello name as a variable, and then we'll print that out. We're going to take a name as a variable, print out hello name. And then that's our task that we only have one in this workflow. And then we have this workflow function, which we just call main. And again, it's taking in a string, and then we're calling this task from there, the hello world, and we're passing in the variable that we take in here called name. And so the only thing that we're doing in this case to make them tasks and workflows is adding these decorators. And again, we'll add some more complexity to this in the next more complex workflow we're going to build. But this is kind of one of the simplest workflows you can build. Now we can run this locally. To run it, we just say union run and then give it the path to the file. So in this case, it's not in a separate folder or anything. We just call simple workflow.py. And then we're calling the workflow here called main. You could have multiple workflows in a single Python file if you wanted. And then we're passing in the variable name. We're going to say Flyte at first. And it's going to return what we would think, hello Flyte. You could change this text variable to workflow. Or I meant to say workshop, but I'm thinking about workflows. So hello workflow, which also kind of works. Now, if we want to run this on the Union platform, so again, this is running locally on the compute in the Colab notebook. So if you were developing locally in VS Code or something, it would be running there. But if you want to run now on the compute cluster where we have access to more CPUs and robust GPUs, we can simply add this remote tag. So same as before, passing in a name parameter here, but we just added this run remote. So go ahead and run that. And it'll take a second here. It's executing on remote. And it's going to generate a link for us to directly click on, and this will bring you to your workflow running. And again, our workflow is very simple here. We just have one node. if we go to the graph, we can see we have start, and then just hello world is running right now, and then we have end. There's also this little timeline section, shows you how long it took for that task to run. So we go to graph. You could go to the node graph. I kind of like the graph view a lot of times, and you can kind of click on this once, and you'll bring up this interface over here that gives you information about the whole workflow, or a task in this case. We have the execution. You can view utilization. We'll see this more when with GPUs right now. It probably won't even show up what we use because it's so small. We have input, so we can see the input was a string called Flyte. We have the output logged here. It says hello Flyte. And then we have some other information around the task. If we want to rerun this, we can easily do it from the UI. So this is really useful too for sharing models that you might want to retrain with different hyperparameters or different data sets, or even you might have a drop down with different models to train and see the performance. So like we're using BERT uncased today, but you could use a different one and see the performance versus another one. So you can just hit rerun task. This brings up a UI where you can type in any string you want. So again, you could type in whatever you want here. I'll type in workshop and relaunch this. But you can kind of get an idea of how powerful this could be to have this UI with a task or workflows that you can easily rerun. And something like hyperparameter tuning is a common use case for that. And then we ran, it already succeeded. And if I go to outputs, now it says hello workshop. We also just hit rerun task, but you could also rerun the entire workflow. Our workflow is only one task in this case, but we can hit relaunch, type in a new parameter there, and get kind of the same results. So this is our very first workflow. It's very simple. We didn't even need a special container for it. It's just running on Python in a default container on Union. If you kind of forget what parameters go into a workflow that you made, it's a useful little thing called help. And I'll say, name is required, but you can also pass in a couple other things. And then we won't go into all these, but there's a whole bunch of other stuff you can do on run. Like by default, I don't think I talked about this. By default in Union or in Flyte, there's going to be two projects. One is called default, one is called system. Default is where everything goes by default. Everything we're going to build today is going to be in here, but you can create separate projects. So if you have a whole bunch of projects in your org, or you just want to separate them more cleanly, you can do that. And then we have this one called systems. Yours will be empty right now, but not for long. This is where container builds are. So we're going to create a container containing specific requirements for our model to run in. And when you kick off a container build, it's going to show up in system. So scroll down. Did everyone, were you able to run that simple workflow? We're going to get onto the more fun one here right now, where we're going to create that container we talked about, download a data set, download a pre-trained model, visualize that data set, fine-tune the BERT model, evaluate the BERT model, and then save the model to Hugging Face Hub, and then also see how we can use that model for inference directly on Union. Someone says, so each task is run in a container. That's right. So every single task is containerized, and the data flow between them. Basically, the data gets serialized and deserialized. And a lot of the times you don't have to think about it as much because Flyte handles it most of the time very easily. Like if you're doing a pandas data frame, there's already functions built in that you don't really have to think about, how do I serialize and deserialize this? It'll handle it for you. But there is built-in stuff called like Flyte file and Flyte directory, which is a specific way to serialize and deserialize data as well. But yeah, so each thing is a container containing the compute that you define, or whatever the default compute is. So in this case, we didn't define any compute. And I believe the default in the serverless Union version is like 1 CPU and 1 gigabyte of RAM. But you can set up what that default is if you're setting up the open source on Flyte, or if you're using Union bring your own compute version, you can set up what that default is. All right, is everyone ready to run the hopefully more fun workflow? And did that make sense? Everyone's good so far? All right, before we run the next workflow, I would suggest creating that Hugging Face token like we did. And we're going to put it into Union secrets. So I can run this, and it says create secret. If you're in dark mode, it's kind of hard to see, but this is a text box here. So you can click on it and then enter some text. If I go back to Hugging Face, I have my token, And I'll quickly go how to get this token again if you didn't follow along the first time. Once you have your Hugging Face account, just hit this little icon that should have your profile picture, or it might be empty if you don't have one there. Go to settings, go to access token, go to create new token, give it any name you want. And then I think we just need write access, but you can do read and, oh, I guess it automatically does read and write if you hit write access. So just check this box and then scroll down and hit create token, and you'll have this token that you can copy over. Once you have it, copy it, put it in that box, and then just hit enter. And for me, it's going to throw an error, and that's because I already have a token with that name. That's okay. But if you are doing this for the first time, you probably don't. And I can actually see all the tokens that I have or secrets that I have stored. So I can say union get secret, and I have a Hugging Face token, OpenAI token, and a couple other ones like weights and biases. All right, so once you have that, and even if you don't have it, that's okay. I would recommend just go ahead and run these first, the next two cells, and then you can come back and put it in. And it's okay if your pipeline fails, but I would recommend running it first, just because the first time you run it, we have to build this image if you don't already have it in Union. And that can take a couple minutes, just like it did when we did it in the notebook here. So what I'm going to do is run this code cell, hit that play button or hit shift enter. And then the one after it, go ahead and run it. And then I'm going to come back and talk about all this code, just so as I'm talking about all that code, this is also running and building your container and running the workflow. And then by the time we come back to it, at least the container build will be done and part of the workflow might be done as well. So then we want to run this next code cell. But before you run it, if you do run it as is, it'll throw an error later in your pipeline. And that's okay. At least it'll still build the container image for us. But I'd recommend putting in this repo ID. And what that is your Hugging Face username. So mine is Sage Codes. You should put in whatever yours is. And then repo ID can be anything you want. It's going to create a new repo if it doesn't already exist. If it already exists with this name, it's going to upload to that repo. So I'm just going to call mine LLM repo. And then I'm going to hit shift enter and run this. And again, if you're running this for the first time, it'll say, like container not found. It's going to build it, and that could take a few minutes. And that's one of the main reasons you want to go ahead and run this. Even if you don't have the Hugging Face account here or the repo, go ahead and run this now. And it's okay if your pipeline fails. We can rerun it with the correct parameters. So mine says image found, skip building. So it's not going to build a new image. And then I can go to this link, and it's going to be running my workflow. So now I'm going to go back to the code and talk about how we built this. So I'm going to scroll all the way to the top. And I think I'm going to go through this kind of high level at first a little bit. But if you have any specific questions, we can come back and look at that part of the code. So let me know in the chat, and or we can come back later after we run our pipeline as well, if you want to dive deeper into anything. So first, we're importing our libraries. You've probably done something like this before in Python. You're importing the libraries you want to use. We have some stuff from Flyte. Again, we'll kind of, I guess, talk about these when we see them in action. I think is going to be better than me talking about them right now. And then we have this part where we're saying image, this is a variable, is equal to image spec. And then we're passing it a list of Python packages. Image spec is something in Flyte where it allows us to build containers without using something like Docker. Now, you could also have a hosted container in a Docker store and then say image is equal to that hosted container. You don't have to build with image spec. But if you don't want to mess around with Docker files and Docker containers, image spec is really cool. Again, in this case, we're just passing in Python packages, but you can get more robust with how you want to build your container image, including like different versions of CUDA or apt-get installing things. So there's a lot of stuff you can tweak in there. In this case, we're just passing in a list of Python files, and it's going to create that container for us just in these few lines of code, which I think is really cool. Do people think this is more interesting or easier than writing a Docker file? I don't know if anyone's written a Docker file and played around with Docker before, but now I feel really spoiled using this because I haven't had to do that in quite some time. So the first task is, we already are building our image. In my case, it's already built. In your case, it's building right now. Now let's go ahead and define all those tasks that we kind of saw in the workflow. Someone said, yes, easier. Yeah, I love it. I love it. It's great. And yeah, people have messed around with Docker and then see image spec and they go, oh, I like this most of the time. All right, so we're going to build our first task, which is downloading a data set. And you can see we have that task parameter decorator like we saw before in a very simple pipeline. But in this case, we're passing in um, a little bit more kind of declarative instructions to it. So we're saying the specific container image we want it to run on. So someone asks, is each task run in a container? It is, and you can define what image you want it to run in. In this case, we're just using one image for the whole thing, but you could have different images per task if you didn't want to load in that specific container image. So you just define it here, and then we're enabling caching. So if you remember from the slides, we talked about you might not want to download the data set every time. So the first time you run this, it's going to download a data set, and then it's going to store it in cache because we hit cache equal true. You can give it a version. So if you want to update the data set and have it stored in a different version of cache, you can, and you can read it back from previous versions. And then we're also requesting specific resources for this container, which we want to run on 2 CPUs and 2 gigabytes of memory. And this is also where you pass GPUs, and we'll see this later. But in this case, we just need a CPU, and then we could define, how many GPUs we want to run on. You can also define the specific accelerator types. So in serverless, I think there's 3 in there right now. T4s, I think the other one is L4s, and then also we have A100. So if you're looking for a place to actually get some resources and train a really large large language model, you can select the accelerated type of A100s. And there's a blog post at the end of the notebook actually talking about that. So if you are looking for A100s right now, it's a cool place to kind of get them and play around with training a big model on a more robust GPU. So then we just have our Python function here. So again, you're really writing this kind of as you would in general, probably as an ML engineer or data scientist if you like writing in Python. The main differences is you have to have it strongly typed. So in here, we're outputting something called a Flyte directory. That's just where we're going to save the data set that we download. And then you have this decorator where you're defining all the stuff that's going on with your task. You're defining how you want that task to run kind of in the decorator here. And then you just have your Python function. So then the next one is download model, very similar to above. This is all the same. And then we're going to download a model from transformers. And we're going to also save this to a model cache as well. And then we're going to have a task that's visualize data set. And this task looks really long. That's because we're generating some HTML with it. And you'll see what this report looks like here in a second. We're passing a container image. We're hitting enable deck called true, which enables something called a Flyte deck. And then we're passing in our compute resources again. Let me actually go ahead and show you what that Flyte deck looks like. Since mine's already done here, I'm going to click on this visualize data. And not only do we have the inputs and outputs like we had before, now we have this button called Flyte deck. I can hit it. And this contains by default things like timeline, source code. So like we had mentioned, all the code is versioned here as well. You can always pull it back down. Inputs and outputs, again, also version. We don't have an output from this cell, so nothing's there. But we can go to this tab called data analysis. And this is what we're going to create in that code that we didn't quite look at yet. But we enable the Flyte deck, and then we can actually put basically any HTML or text here. So in this case, we have this data analysis tab. You can change the name of the tab, the order of them. Then we have some summary statistics about our data set. So in this case, it talks about training data. What is the shape of that? In this case, we have 25,000 rows of data. And then I loaded in one example from both positive reviews and negative reviews. So the data set here is a sentiment data set on movie reviews where it contains 2 classes, positive and negative reviews. And this is a whole bunch of text. And then we're going to fine tune our model basically on a whole bunch of samples of these, and then we can pass it new data and it can predict, was it positive or negative. So it's kind of a cool way to visualize your data set here. I almost always do something like this when I build a AI model or ML pipeline, because I've had it in the past where I swore I was loading in data correctly, and then when I actually looked at it, I wasn't. So I always like to have like some samples of what the actual data looks like after pre-processing or something like that. Here we also this is a little bit overkill for this data set, but we have a chart showing the distribution of labels. So in this case, it's just 50-50, but this can be really interesting too. Like if you want to look at what is your training data set distribution, you can log that here. And then it does the same thing for the test data set that we'll evaluate the model on. So really cool way for you to embed a lot of information about what happened in that task. That could be when you're training a model. We don't do it here, but when you're training a model, you might want to save, accuracy and like loss per cycle or epoch of the training. And you could have that as a chart here. And then every time you come back to this version of the workflow, it's logged here. And if you create a new workflow with a different model or different parameters or different data, you can always go back and reference all of them, which is really neat and gives you a lot of traceability into everything that happened. So let's see how we build that. We have our visualize data function. And we're passing in the data set cache that we just downloaded. And then we're setting this to current contacts. That basically just allows us to access things specifically in the task. And then we're loading in the IMDb data set. That's what the data set's called, positive and negative reviews. We're getting 2 data frames, train and test. We're enabling or creating this deck object, which is the thing we just saw with the title, which is data analysis. And then we're basically just getting the top the top 2 reviews of both negative and positive reviews here. And then again, this looks like a lot. This is because we're creating those charts in Plotly. And we're converting those charts to base 64 so they can be rendered directly as HTML. And then this is the HTML that we actually render. So you can have this as a F string, put in any HTML you want, and then pass in Python variable. So again, very flexible for you to build really cool reports built into every task here that you can always go look at. Then we just append the HTML to the deck. And then this is inserting it at place 0. So that's why it's the first tab, but you can move it around. And by default, it's not the first tab. So that's our visualize data task. And then we have our train model. So we loaded in our data. The main thing here to call out is now we're requesting more compute. We're requesting a larger GPU, more CPUs, and way more memory to load in our model. We're loading in the BERT sequence for classification model, and that's what is being returned from this. And we need the model name, the data set location, the model weight location that we downloaded. And then by default, it's going to be training on 3 epochs. So it's going to be looking at the data that we pass in 3 times. That might not be nearly enough to get a real good model, but it's enough for us to get a result and in a timely manner for the workshop. Otherwise, it can take a lot more. So you might want to come back and adjust this to be way more. You can also do it when we call the model from Union or do it in the UI. And I'll show you how to do that when we get to that part. Loading in the data. Again, I'm going to kind of go through quickly so we can look at our workflow. But if you want me to come back to this, you can. We're passing in hyperparameters basically, or parameters to our model. So we're saying like the number of labels is 2. These are the ID to label and label to ID. Basically, we just have 2, in this case, negative and positive. And then tokenizing our text, which if you're not familiar with tokenizers, they're the way of how text is broken down for your ML model. And there's different ways to chunk them. And every model usually has one that it like learned from. So you want to use that same one like when you're training it. In this case, we're only using a small sample of our data. We're going to train on 500 rows and then evaluate on 100 of the test data set. So again, mainly for the workshop to make sure that this trains pretty fast. We're just doing a small sample, but you could up this to that 25,000 and your model would probably be more robust than what we're going to get here with only 500 samples in 3 cycles. We're going to be computing our metrics to basically give us an accuracy score so we can see when our model is getting more accurate. We're going to pass in arguments to our model. We're using something called trainer in Hugging Face. So we say trainer is equal to trainer and then passing these parameters. And it's another abstraction kind of on top of PyTorch and training LLMs here. So again, it makes it kind of easier, a built-in Hugging Face thing. We pass in that model that we had downloaded, all the training arguments that we had defined up above, and then the small data set, the small evaluation data set, and then the compute metrics function. And then we just say trainer.train. And if you're super new to this, I know it might seem like we went through a lot of this pretty fast. It's also high level abstractions on a lot of stuff. But don't worry, you'll be able to run this code cell and come back and actually, kind of change these parameters, I think, too, and rerun a model with the parameters that you want. So that's our trained model. And then we're going to evaluate our model. So we're going to take in that model. We're going to then run it kind of on the test data set. So again, loading in the test data set and model here. Kind of similar to what we did above, except for we're computing the metrics. We're getting accuracy, F1 score, precision, and recall, which you might be familiar with those if you've done machine learning before. And then we're just going to run it on the test data set instead of the training data set. And then we'll get the evaluation results, and then we'll return all those results. And then we have the save model. This is where we're going to actually use that Hugging Face token that we saved into secrets. So again, something to call it here that we haven't seen before is passing in secrets. So remember, we saved that Hugging Face model or Hugging Face token. Then we're going to say we want to bring in that token to this container, and then we can use it in this case to upload our model. So here's our function here, taking in that model. We are going to save that model. And then where there's two files we want to kind of loop through and upload to Hugging Face. So the way it works here is we have tensors that are saved and then a configuration file in JSON for each of those files. We're going to loop through and then save those files into the Hugging Face hub. And that actually happens down here. I'm going to scroll down. This is also built, so if you do have a local environment token for Hugging Face, you can use this locally as well. I'm just going to check if there's none, then go ahead and get the secret from the context of the task that we passed in. Otherwise, it'll be using it from the environment. So if you're using something like .env, you can save a token in there. And this is the actual upload part. So we initialize the Hugging Face API. We create a repo. We pass in this exists okay equal true. That means when we call this, if it already exists, that's fine. It won't throw an error, and it will just upload the files that we pass in to that. Otherwise, you could get rid of this, and it'll say, hey, that repo already exists, and give you a warning. Otherwise, it's going to create this repo if it doesn't already exist. And then we're going to loop through those files, and this is the actual upload part where we call api.uploadFile, pass in the path of the file locally, the path in the repo. So this is the name that we want it to be in the repo when we upload it, the repo name, which again, mine was LLM repo when I called it before. And then a commit message. You could change this to be whatever you want. Repo type is equal to none. They have a couple different repo types, like one specific for data set. We're just doing none, and that's kind of a default one where you can upload files to. And then we pass in our Hugging Face token, and then it'll get uploaded. And then our one more task here is predict sentiment. Nothing really new here, except for we did add something here called retries. So if this did fail once, it'll retry it a second time. And then we have our function predict sentiment, takes in that model, takes in new text, which is a string, takes in that model cache, and basically we just pass in new data and call get a prediction from that model, and it'll say is it negative or positive, and give us a percentage, like a confidence percentage. So now we have this workflow, which, remember, a workflow is kind of how we tie together all those tasks and create the pipeline. So this is where we really define the flow of our data and the flow of those tasks. And we're basically just calling all those tasks that we created: download dataset, download model. We're passing in different parameters like the model name. That model gets saved and then gets passed to the evaluate model. Again, kind of building out this DAG here. So this whole flow is defined in this workflow area, and we defined all the tasks above with that task decorator. And did anyone's image like build, or did your whole pipeline run yet? So we just went through a lot. It's a very quick kind of crash course, I guess, on building tasks and workflows. But yeah, did anyone, were you able to run this workflow? RB said, yes, it's done. Awesome. So again, you can go in here. Now you could click on these and see, what happened. Again, this one, we just had an output, which was the data set. This one, we had an output, which is the model. Here's our train model, which we had an input. We can look at, this was the training data set and the downloaded model. And our output was a fine-tuned model. And then we pass that to evaluate model. And oh wait, did I put this in a Flyte deck? Oh, I think I enabled the flight deck, but I didn't. I guess I didn't make a beautiful HTML report, but we can see that in the outputs here, we have our model that we trained. The accuracy on the evaluation data set is 87% or 88. And then F1 score, all these other data here. Again, we could have this in a more beautiful HTML report if we wanted, but we do have the inputs and outputs here logged as well. And again, this is just on 3 epochs and a small sample size of the data set. And then if we go down, we said saved model. The output was model uploaded to Hugging Face repo. So if you are in your Hugging Face account still, and you go to just your profile page, scroll down, you'll see that you have a repo here now with whatever the name is that you passed. Mine was updated 6 minutes ago when I ran that workflow. And I can go to files and versions, and I have this the safe tensors file and the config JSON, so I could re-download this now and run this model kind of anywhere I want. Go back to my workflow. The predict sentiment. So we passed in by default when we ran it here. Oh, sorry, we didn't pass in text here. By default, it's going to use this "I love this movie" as text, but we could pass a new text, which we'll see here in a second with the Python API again. But also, if we just kind of want to see how this model does on text that maybe isn't in the evaluation data set or isn't in the training data set, we can rerun this task right from the UI. We'll see again how to do this in the Python SDK in a second, but we can go ahead and hit rerun and then scroll down and see there's this area for text. This is what it's going to predict sentiment on. So this new data is going into the model and then getting the prediction back. So what's some text that we should pass in here? And I encourage you to follow along and do this from your UI. Someone asked, can we get GPU RAM more than 4 gigabytes? Look at, so the accelerators, there's a link at the end of the notebook to a blog post talking about accelerator types that you can choose from. And you should be able to get one like the A100s, I believe, have more. Are the other ones only 4 gigabytes? I'll have to look at that. I'm actually not sure if are T4 is 4 gigabytes? Is that what the 4 stands for? All right, so I'm going to pass a new text. Maybe we can be a little bit more vague too than "I love this movie." So I'll be like, why did this movie have 40 minutes of farming wheat? It's a question mark. So this isn't quite clear, I guess, if this would be like positive or negative. Like the other one says love, that's often, associated with positivity. So let me hit launch again on this task. And now we have this task that's just relaunched. Again, we can look at graph mode, and it'll take a minute because, again, it has to spin up a container kind of every time it does this. So this is really good for actually, you have a model up here. Someone said, haha, I think for what I typed in. Do you know what movie I'm talking about? I don't know if anyone watched Rebel Moon Part 2, but there's like this way too much farming in there and not enough character development on it. I thought it was really funny. So now we have this model up here that we can call. In this case, we're doing it from the UI, but we can also do this from an API. But we really have a hosted model that's deployed in a way. Now, since it has to spin up a container each time, this is good if you want to do something like batch processing and you don't mind waiting. This wasn't that long, right? But you don't mind waiting the extra 30 seconds or a minute for a container to spin up and give you prediction results. It's really good for batch processing. Actually, a lot of people use it in that way. But there's a little bit more latency where maybe you don't want it in like a live chatbot. But it's pretty common where you might pass up a whole bunch of files or something, get a prediction on them, and then it's spin down that compute. So here we can look at my new input. Why did this movie have 40 minutes of farming wheat? And I can see this is a very high confidence that was a negative comment about the movie. So our model definitely learned something from that data, even though it was a pretty small sample of it. Now, I'm going to go back to the notebook, and we're going to do kind of the same thing, but do it from the API here. And so you could actually take what we're going to do here and deploy it in something like a Gradio app or a Streamlit app if you want to have an interface that goes to Union, like a Union hosted model. Also, quickly note, so we had it where you could pass in, different hyperparameters. So I won't relaunch the whole thing right now, actually, but if I go back, you can always go back to your dashboard, get all the list of the previous runs you've done. We're going to go back to this BERT fine tune. I can relaunch that workflow like I showed before on the simple one, but now I can pass in different parameters as well. So I don't have this quite set up in there to actually take in a new model type, but you can easily do a couple adjustments to the code where you could pass in different models. You can pass in different epochs here. So again, it would only train on 3 cycles of the data. We could pass in way more and it would probably be better. Then you can pass in a different repo. You could pass in that text that you want to do the extra evaluation on. So then you could just hit launch and it'll relaunch the whole workflow with these new parameters that you defined. And again, really powerful for doing things like testing on different hyperparameters and different data sets very easily. So you already have a whole pipeline defined and it's really easy to rerun it basically. So we talked about building that loop kind of at the beginning where you might get new data and you want to retrain your model and see how that model is doing. Very easy to do. And you get a version every time. So we talked about, you get caching, you get versioning. So you have a version of all those artifacts in place. You can rerun the model, and then you can always go back and get those different versions and compare them. So let's quickly kind of do what we did through the UI, but in the Python API. So we have this model up there. We have these tasks and executions. We can look at them just kind of like all the stuff we did in the UI, but through the API. So this is really useful. Again, if you want to build your own application with something like Gradio, you could put that in a Hugging Face space and point to this model at Union, or Streamlit, or you might want to run this off of like a Raspberry Pi, talking to the API. You can do that pretty easily using this. So we're going to initialize something called Union Remote. And then we're going to basically just look at all the recent executions. I'm going to limit it to the last 10 because I have a lot in mine. You probably don't have that many, so it'll probably just show 1 or 2. And then for each of those executions, I'm going to look and only return the ones that have this name, which is the BERT fine-tune.BERT BERT FT, which is the name of our workflow. So I'm only going to get this workflow, but you can access all of them from the API if you wanted to. And let's see what that looks like. So here's a whole list of all those executions. Again, I have several in mine, but you might only have one if you're just following along and only ran the workflow once. And then I'm going to get the most recent execution. So that's going to be the one that we just finished during the workshop. And I'm going to get this ID returned. And I could go look at, you don't have to verify this, but if I wanted to, you could go verify. I see this string up here, this hash. That's the version of the workflow. And now we basically have that version identified here. And then we can kind of call those different executions again if we want it, which is what we're going to do here. So I'm also going to, so I'm going to fetch the execution, which basically gives me access now to all those artifacts and what was done. And I'm going to look at outputs from there. So at the workflow output, we returned the model and the accuracy and everything like that. I'm going to get the first 2, which is the model that we fine-tuned and then the model cache that we downloaded from Hugging Face. And I can see these are kind of the URIs for them. So where they are living right now in the remote environment. And then I'm going to fetch the just predict sentiment task that we reran. And you can specify specific versions if you want to. I think by default, it's the latest one. And then now I have my task. I have some info around it, like what it takes. It takes in inputs, which is a model type, and it also takes in a cache and text. And by default, it's gonna run on 1 GPU and the memory we defined and the compute we defined. And now I'm going to rerun this task from the Python API. So again, you could set up a little app to do this somewhere else and get prediction results returned. So here I'm going to define a input dictionary, which and why did this have 40 minutes of farming wheat? Again, put in different text you want. Then we're going to get the model cache that we pulled down from the previous execution. Same with the model file. And then we're going to call remote execute, and it's going to pass in those inputs and then call that task. And it generates this link to bring us to that task. and then we can see it's running, and we called it from the API. If you wanted to, you can also put this wait equal true when you call it. And what that's going to do is instead of generating a link for us to go preview what's going on, it'll actually just wait until the execution is done and then return that variable or return the output. So again, really useful if you want to build a little Gradio app. You can just do this, and then as it's executing, it'll just wait and then pass in the data once it's done. So again, this should take just a few seconds here to run. Once that is done, we can call this remote.sync on the execution that we created, and it's going to get the latest version of it. So right now, if I call it and look at it, if it's not done yet, I might have been too late to call it and not get it done. Let me see. Yeah, so I call this, and it basically syncs the current state of it. So if you called this before it was done, it wouldn't have outputs. And then if you ran this code cell, it would say, hey, there's no outputs exist yet. But they do already. So we fetched the synced version of that specific execution that we just called. And then we're getting the outputs. And then now we get that score of, it's 98% sure that it's negative, and it gets the label negative. So again, we have this deployed model. We can call it from an API, which is really cool. And a quick note, if you're doing this in production, I would definitely look at using something called Union artifacts. This isn't fully in the Flyte open source. I think parts of it are, and you could kind of build out your own if you wanted to. But in Union, we have something called artifacts. And so instead of passing the data like we did, where we're treating everything as a function, all the executions as functions, getting data out, passing them into another function, you actually have something where you can define an artifact. And I think there's a good graphic in here somewhere. I forget which one. Which one was I going to show? Basically, you create an artifact, and then you can have that as like your data set or model, and then just reference that artifact, and it makes it a little bit cleaner to call the data, but also you kind of have like a state of that data that you can manage versus kind of like you're kind of like tying and stringing together these different functions the way we just did it. And I would recommend using artifacts. It just makes it cleaner. And you have like the state, and then also in the UI, if you go to artifacts, you won't have anything here because you didn't run one yet, but you also get a visual of all the lineage. So it's really cool. You can see the initialization of that artifact and then where it's being used, and if you did something else with it. So you get this kind of nice graph of where your data came from, all the stuff that happened to it, and where you're using it. So I'd recommend doing that. And then another thing is like we just had that task as part of our workflow, and it does work to call just a single task, but you might want to make a separate inference workflow. And that is useful too, especially if you need to build out more stuff as part of your inference pipeline. You might not just have a single task. Maybe you're going to have a pre-processing task and then the prediction task. Build it as a workflow, but then a very similar way where you can call it via the API that we just did. And then there's a lot of other things for you to check out potentially. Check out building RAG on Union, which also uses artifacts like I talked about. But you can have a version of RAG and a API where then again, just like we did here, you could call it and access your vector database and get results returned. There's a whole video tutorial for it as well. You can also go to this A100's blog post, like I mentioned, if you want to use more robust compute, you can check it out there. And then also, I didn't mention this. I think I usually bring it up at the beginning, but I don't think I did this time. LinkedIn switched all of their large language model workflows to Flyte, and they did a really cool guest talk on it last month, where you can check out like what their actual infrastructure looks like around it and see how they're using it at scale inside the company. With that, that's kind of the last parts of the workshop I actually have. And I see, people are still here. Let me know in the chat. Was this interesting? Was this cool? Did it feel easy? Were parts of it hard? What example would you want to see next? Like we went and fine-tuned a BERT model. Is there something else that you'd like to check out or like see an example of? Someone said link, please. Yeah, so all these links are in the notebook at the bottom, but I'll share them in the chat as well. That's a YouTube recording of a live event we did with them. Yep, I sent a link to the Flyte talk in the chat. I guess I can also get these other links too. Yep. So, what do people think? Was this interesting? Was this a interesting introduction to building a pipeline for fine tuning a large language model? Are you going to use Union serverless to build something? And I will also link this RAG one. There's a full code example and stuff again, so you could just run the kind of workshop here or check out the recording for it as well. Someone said, surely. I hope so. And if you do, talk about it. Let me know. Either if you want to ping me sometime or join the Flyte Slack channel and say hello there and share what you're working on. I always think it's really cool to see what people are building. And the Slack channel is a great place if you have questions like after the workshop, you're building something with Flyte or Union, post it there. And there's a whole bunch of people that can answer your questions. So not just us at Union, again, it's a really active community of open source contributors. Someone said they think their question is not visible to me. Yeah, I did not see a new question from you, RB. If you want to try to post it again, you can. If for some reason it's not showing up here, ping me on LinkedIn or post it in the Slack channel. But yeah, I don't see a question from you. Again, if anyone has a specific example they'd like to see, that'd be fun to hear about too. Like, is there something that you're building and you'd love to see like a pipeline example, kind of like we built today, but to your specific use case, or maybe integrating a tool that you're using? One thing I definitely want to do is build out more examples with a lot of the tools I love as well. So if you have any you want to shout out, let me know. And well, I still see quite a few people hanging around. So definitely let me know, like if you have questions or ideas, what you want to build together here next time. Also, while people are waiting around, I think I have. Let's see, will this work? Yeah, if you wanted to run a, oh, cool. People have questions, so instead of doing that, I'll come back to the question. Someone said, "Can you summarize the fine tuning you did for the IMDb dataset and then inferencing?" So let me go back to the code here. And we have this section, which is train model. And this is kind of like if you have really deeper questions, then maybe I can answer, um, or sometimes it's hard talking through text for your question. There's some blog posts like on Hugging Face. I'll try to find a link maybe later and send it to you. There's some really good blog posts basically doing what we're doing here, except for not in a ML pipeline kind of situation, not in a task. And this kind of IMDb data set is a pretty common example of like fine tuning a BERT model or an LLM in general. It's kind of like a lightweightish data set, and you can get some good results from it very quickly. But I can walk through this again. I'm not sure if you have a specific part that you'd want to talk about, so I can just go from the top here. But if you have anything specific, let me know. We have our function train model, passing in the model and the model name and the directory where we downloaded that model weights, the model weights, like the pre-trained model. So we're taking a model from Hugging Face Transformers, we're downloading it, and then we're going to pass in new data for it to learn from. So it has pre-existing understandings of some text that it was already trained on. And then we're going to pass in new text data, which in this case is just movie reviews. And then we're going to pass in two labels or pass an A label for each one. And there's only two labels that exist, which is positive or negative. And it's going to learn from those labels of what is positive or negative. And in this case, we're importing something specific called, let's see, I think we imported at the top, a BERT for sequence classification. So we're going to train a BERT model, which is a type of transformers that was, I think, by Google, and they were kind of like I mentioned, BERT models were kind of really the first ones that got, I feel like, at least from my perspective, like a lot of hype in the industry. Maybe not, not as much as ChatGPT, where everyone started using it, but a lot of people I knew were training BERT models for specific NLP tasks, and they did pretty good. So there's a specific one called for sequence classification, which is doing a classification task where we're just returning a positive, in this case, a positive or negative label, a 1 or a 0. We're loading in the data set, loading in something called auto tokenizer from BERT, and they actually have something too that's auto model for sequence classification. And I think I use this here, but in this case, we well, yeah, we could easily edit this. I think I started making this so that I could pass in a different model name and it would download um, a different one. Like by default, if I go back to my execution, by default, the model is a BERT based on case, but there's different BERT models for classification that you can use. And then so we could change the model out. I think some of our other tasks just have that BERT base uncased hard coded in, but we can make it so we could switch our model pretty easily. And then passing in a number of labels, and then it's pretty common where you pass in something called ID to label, and then something called label to ID. Basically, they're the reverse of each other, but you're giving a dictionary of numbers to text and from text to numbers, and they're passing in the downloaded weights that we have. Um, and then we're doing a tokenizer function, which is passing in the examples. We're getting the text from it, and then we're adding something max or adding max padding length. Sorry, padding for padding. We're adding max length, and then we're truncating the text. So if you haven't done tokenization before, there's a lot of pre-built things in Hugging Face that kind of make this easy. And again, tokenization is how you kind of chunk up the words or text. So there's different ways of doing it, and there's a lot of different varying results on how you do it. Like you could chunk up every single letter of a word. You could chunk up parts of a word. You can chunk up full words. Definitely look into tokenization if you're kind of new to it. But basically, there's just different ways of doing it, and you want to make sure that you're doing it kind of the way that the model was trained on. We're getting that small data set. Somebody said amazing workshop. Thank you. They also asked what kind of RAG chunking do you implement? We didn't do RAG in this workshop. And I don't know. I know I've done it a couple of different ways. I don't have like a big bias towards, I guess, a specific one right now until I evaluate it. I'm sure. Have you played around with different types of chunking for RAG applications? I'll definitely get more into it when I'm going to be building out probably some more RAG examples this month or next month in September. And so we'll probably get way into looking at different types of chunking and how to maybe do evaluation metrics on them. But yeah, and then there's a big abstraction here for in Hugging Face. There's something called trainer. So once you basically download the model and add those kind of different parameters in of like what model you had and what tokenization you had, you just call this trainer.train after passing in the model, the training arguments, the data set, the evaluation data set, and whatever metrics you want to compute for it. So it might have felt really like easy. That's because Hugging Face has a lot of built-in stuff that kind of makes it easy for us, which is really cool. And they have something called auto tokenizer that you can use like when you download a model to see what tokenization it used and then use that on the data set that you want to train on. I don't know if that answered your question, but maybe it did. Awesome. And yeah, any other questions? I'll be sticking around for a little bit more. I know, we're way over time, but it's awesome. There's still so many people here asking questions. Again, if you have any examples, like George, you're talking about RAG. Are you building a RAG application right now? And would you like to see an example of building a pipeline for RAG? And if you are, I'd love to hear actually even like what type of application you're building with RAG. What's it doing? And RB said, you sent me a message somewhere else. Let me go see if I can find it. Oh, and also note, so I talked about, we had the model deployed, interacted it through, I can't talk anymore, interacted with it through the API. And I mentioned it's really good for batch processing right now, where it's okay taking a minute or so to spin up that container. We're working on some new features and stuff to make that faster and some other options of like hosting models here. Someone said, loved the workshop. We'll connect with you on LinkedIn. Awesome. Yeah. Thank you so much for coming and asking great questions. Again, I always really appreciate people who talk in the chat. I mean, it's great if you're here not talking too, but definitely appreciate everyone in the chat giving me feedback, and just talking during the workshop makes it way more fun for me, and seeing that people are actually following along. And RB, I'm going to see if I can find your message real quick. It said, can you use Union while writing the script of an API? For example, like if you wanted to use fast API. So yeah, you could use something. Maybe this would be a good example for me to think about too. So you can use something like fast API to interact with the Python API like we have here. So if you wanted to pass in data and then get a result returned, you could definitely do something like that. I think that's what you're asking. You could certainly do something like that. Yeah, it'd be fairly easy to take kind of what we did in this last portion and build, another little API wrap around it, or a user interface. So I'm actually going to build some examples probably with this using Gradio or Streamlit. And then you can host it in a Streamlit space or a Gradio space and actually come away kind of with a deployed application here, which would be pretty cool. And you already have a Hugging Face account now, if you followed along. So you have a Hugging Face account, and you get free Hugging Face spaces, which I think they just give you CPUs for free. But you could host a little app like this here and call it, which would be cool. Any other questions? If not, I'll wrap up the stream here in a couple minutes. And again, we built a pretty robust workflow, and again, it was really fast. We went through it pretty fast. Hopefully, you feel like you learned some new stuff, and definitely, give yourself a round of applause if you followed along and built this. This might have felt easy or could have felt hard, depending on your experience. But we really built kind of a version of a state of the art pipeline here that is commonly used in production. We have our caching enabled. So we can see the data set here. I didn't download it again because it just reread it from memory. We have all the versioning in place. We have access to GPUs that we can run our model on. We have this all stored, like the version of our data set. We can go back and look at the analysis every time if we had questions about it. And also, you can, define this pipeline however you want. In this case, I broke out the visualized data. You could have that as download data set and then just store the visualizations there. Part of the reason is, I forget if I mentioned this earlier, but part of the reason is a lot of times if you have maybe less unclean data, like the data set from Hugging Face is very clean. We don't have to do anything to it really. A lot of times I have a task that does pre-processing of the data, and then I also want to visualize it there. And so I have that broken out. But in this case, we didn't really do any pre-processing, so we don't really need this as its own task. You could kind of combine it with download data if you wanted. But again, it's up to you how you want to build your pipeline. Any other questions or recommendations for projects to build next? I'm going to drink some coffee, see if any other comments come in. And if not, then I'll wrap up the stream. Thank you again for everyone who attended. Saw quite a few people watching, and especially shout out to everyone who put a comment in the chat. Right, I see no new comments, so I think I will hit the end stream, even though I see there's still quite a few people watching the stream. All right, I'm gonna hit end now, and if you have questions later, join the Slack channel, connect with me on LinkedIn, and feel free to ask them there. So if you want to take this, build your own pipeline, run a different model in here, try it with a different data set. If you run into any errors or just have any questions, connect with me in either of those places, and I will hopefully talk to some of you all next time. This was really fun. Thank you, everyone who came out. Talk to you all later.